Welcome everybody, we are the Linde Group, and without losing much time, I'm going to hand over to our presenters, Jennifer and James.
Thank you for your nice introduction. I will now briefly show you our team slide. Our team consists of 6 developers from 5 different countries. I would also like to take this opportunity to thank our customers, Dr. Stefan Lenz and Dr. Dächen Lu, for being very helpful and enthusiastic. I will now give you some background information on Linde before we jump into the visionary scenario. Linde is the world's largest industrial gas company. In Germany alone, they have more than 20,000 customers. In order to deliver their gas cylinders to the customers, they use more than 100 trucks every day. Worldwide, Linde spends more than 100 million euros every year just on transportation. Let's now imagine the following visionary scenario. Imagine a fleet of 1,000 delivery trucks. Each truck is equipped with smart sensors. Information gathered by the truck network allows each and every driver to always take the most efficient route. Customers can get live information about their tour at any given time. In a first step towards this vision, we are currently working on 4 different systems. First, there's the planning app. At the moment, Linde has to pre-plan a tour that a truck has to take. Unfortunately, as you can imagine, these plans do not always work out in real life, and trucks get delayed. Our planning app will show when, where, and why a truck got delayed. Our first requirement is to show a searchable history of truck tours. A user can then select a specific tour and view the details. Next, we also got the truck app. Right now, Linde has no possibility to find out whether a truck is loading, unloading, or just waiting at the customer side. We want to detect the status of a truck automatically. We also will gather the information, the GPS information of the truck, so the tour can later be viewed in the planning app. However, sometimes a truck gets delayed despite your best efforts. Therefore, we are implementing a chatbot system. The customer can use the chatbot to get more precise data about his delivery. We also have a server. The server will analyze the data that was gathered by the truck app and help with future routing. So much for our requirements. I will now hand over to James, and he will show you our analysis object model.
Thanks, Jennifer. In order to give you an idea of what the objects involved are, I'd like to show you an exemplary scenario of how our project might be used. It starts off with the tour, which is the route that a truck takes on a given day. This tour passes through several geopoints, essentially coordinates on a map. In this case, they're delivery points, which mark the location of a customer. As the truck drives along this tour, it leaves waypoints tracking its location. Should something unexpected occur en route, we have an incident point representing this. The truck's diversion around the incident point is, of course, also tracked by waypoints. And all of these objects I've shown you make up our analysis object model. As you can see, we have our geopoint at the top, and the 3 other points I mentioned inherit from it. 2 delivery points and some waypoints make up a segment, and several segments make up a tour. Naturally, a tour might also have incident points, and it definitely has a truck. The truck is equipped with sensors, and every delivery point belongs to a customer. So you can get a better idea of how this looks in practice. I'd like to show you our trailer.
For our little demo, we have Stevica playing the path planner, we have Branislav playing the truck driver, and I will be the customer waiting at the customer side for his delivery.
Hi, Stevica, good morning. I just came to pick up my delivery sheet for today. Do you maybe have it?
Hi, Branislav. Just one moment. Here you are.
Oh, thank you, thank
Have
you.
a nice day and
See you tonight.
afterwards.
See you.
Hey, Branislav, just a moment. We are currently working on optimizing our path planning system. Can you maybe take this iPad to help us out?
Yeah, sure, but what should I do with it?
You just put it on your truck and it will monitor your drive and we will learn from your driver's experience. The sensors are already set up on your truck.
Oh, great. Thank you. See you this evening.
You're welcome. See you afterwards.
So Branislav is now heading for the customer side to deliver the cylinders I requested. Unfortunately, he runs into a traffic jam caused by a construction site. This will cause him to take 1 additional hour, and I'm starting to wonder where my delivery is.
I'm really sorry I'm late. There was some horrible traffic jam. I'm really sorry.
Well, I guess that happens. You can just start unloading cylinders right here. That will do.
Thank you, thank you.
So while Branislav is unloading the cylinders, the sensors record the duration of the whole process.
Thank you. See you next time.
Have a good ride back home. Bye.
Sorry, Stevica, I'm late. I had some issue on the road here, so there was some traffic jam. I'm really sorry.
Hey, Branislav.
This is my delivery sheet for today.
It's not a problem. I have everything recorded here.
Oh, really?
Yeah, so let's have a look. So here we can see our rides, and now let's search for today's ride. Here it is. Okay, here as we can see we have our path, planned path, and here there's something with red that must be an incident. Let's have a closer look. Okay, here it says that because of construction site, we had a 1 hour delay. We should definitely take this into account when we are planning in the future.
Yeah, that's true, really. Thank you for showing me this one.
You're
Thank
welcome.
you. See you tomorrow.
See you.
See you.
Bye.
Bye.
All right, now that you've seen our system in practice, let's pop open the hood and see what's going on underneath. We can divide our top-level design into 3 parts. The input on the left, which are our truck sensors, existing infrastructure in place at Linde that provides path planning, and an external server for traffic and weather data. All of this gets fed into our analysis hub, which processes it and proceeds to spit out customer info to the truck driver, real-life data, what's going on right now, to the path planner, and of course, live feedback to the warehouse worker via our chatbot. Since the analysis hub is really the core of this operation, let's take a closer look at the subsystem decomposition of it. We start off with a plan from the legacy systems that is provided both to the truck driver and to the path planner and provides basically the status quo of the route planning. While the truck is driving, sensors generate both geodata and loading status, which is fused together to form information about the current segment. And this segment then gets passed on to the customer on request via the chatbot. And furthermore, it's saved in order to be fused at the end of the day with the external server data to generate analytics about what went wrong in the path planning and how this path planning can be improved in the future so that future routes will no longer run into these incidents. As far as our status goes, on the planner app, we can already display the list of tours, but searching and details are still a work in progress. And on the truck app, as you saw, our sensors work quite well, but we'd still like to improve robustness. And one major outstanding issue is that neither of the apps display the shipping note yet. This is one of our top priorities, and on the chatbot and the server, we already have a working SMS bot, but sadly it doesn't deliver any live information yet. And data analysis is our next big step. And on Monday, we will begin recording data from real tours. And I look forward to being able to show you the results of this data analysis at the CAT. Thank you very much for your attention. Are there any questions?
Thank you very much. This is really amazing. I like it very much. It's quite extensive work that you did right now. What do you think are the major challenges in finishing this project?
The major challenges I see are, first of all, ensuring we have robust hardware that will stand up to the abuse it would take on the bed of a truck. And second of all, getting enough data to be able to really perform useful analysis in the short time left.
Okay. Thank you.
Thank you.